Okay, guys, Algebra 1, Module 1, Lesson 16. It comes on the heels of Lesson 15, where we began to look at compound equations, compound inequalities, and using the word, or interpreting, rather, the word and or. And one of the things that we want to remember from Lesson 15 is that if we are using the word and, both of the inequalities or equations have to be true. And if we're using the word or, only one of them has to be true for the compound inequality or equation to be true itself. So let's start with the objective. Students solve two inequalities joined by, quote, and unquote, or, quote, or, unquote, and then graph the solution set on the number line. So we're going to be solving and graphing, and that's basically what we're doing. So it's very similar to Lesson 15. Let's start with looking at some of the exercises the book presented to us. Some of the things you're going to be asked to do is to consider a varying array of equations or inequalities. In this case, you'll notice that we have an equation where we're told to solve this. W squared is equal to 121. Well, if you take your calculator out, in order to solve this one, we actually have to take, if you recall from previous lessons, we have to take the square root of both sides, and we get W is equal to a positive and a negative 11. So we always do the opposite operation of what's happening to the variable. In this case, W is being squared. So what's the opposite of that? Square root. And that's where they're getting the answers. W is equal to plus 11 and minus 11. There's actually two solutions there. And then they graph it. Simple enough. In B, you'll notice that the inequality, W squared, is less than 121. So they use the same numbers. And so this allows us to consider, well, how does that look on a graph? And when they solve, you'll notice that as a compound inequality, it looks like this. You could also write that as W is greater than negative 11 and W is less than 11. This is the same thing as that. Keep that in mind. We learned that in Lesson 15. And of course, the graph, you'll notice that at negative 11 and 11, it's open because it's not equal to. Because we have these two inequalities, you notice that it's open. The circles are open. Okay? So then we go forward, and the next one is the same inequality, W squared greater than or equal to 121, except your inequality is switched. In this particular case, you will note that W is less than or equal to negative 11 and W is greater to. How did that switch? Well, let's just take a look. If you trial and error, if you use trial and error, you will be able to see that these values here and these values here satisfy the individual inequalities. Anything in between negative 11 and 11 do not satisfy them. And so A, B, and C are examples of the same inequality, just changing the symbol from equals to less than to greater than or equal to. And that's, in effect, the difference. In the next problem, they bring us a different type of equation. So in this case, we get this, where the only difference is inside the x, or inside what's being squared, is x plus 7 instead of just x. So how do we solve this? Well, over here on the side, how I would solve this is simply the same way I solved the previous problem. I would take the square root of both sides, just like I did up in the original problem. And that gives me x plus 7 is equal to a positive and a negative 11. And these are two separate ones. X plus 7 is equal to 11, and x plus 7 is equal to a negative 11. So I'm going to solve individually, and I get x is equal to 4, and I get x is equal to a negative 18. And so there we can see how they're getting the negative 18 and the 4. Now, according to what we saw in the previous example, the next two should be fairly easy. Pause the video and try I and Roman numeral 1 rather, and Roman numeral 2. Okay, you've had a chance to do this, so I'm going to go ahead and do Roman numeral 1 and 2. See if it matches up with yours. So we already know that the solutions. We already know that the solutions are here at 4 and here at x is equal to a negative 18 in the original problem. This time, though, we have different symbols. Less than on the left and greater than or equal to on the right. Similar to the previous problem, we're going to actually see that the graphs are practically the same. In this case, if we put negative 18 here and we put 4 here, just a quick graph, we know in this particular case, it's going to be open, and then our actual graph is going to be in between. Because this is an and situation. Both have to be true. And in this particular case, you will notice, similar to the one above, this one is going to be off to the left, and we're going to color it in because it's equal to, and off to the right. And this is an or situation. Okay, so if you had those, great. We're going to do some more work on this as we move forward. So we keep going, and you'll see now we have to consider some more examples. And you'll see here, I've given you the answer for A, B, and C. Write the inequality as a compound statement inequality. So they give us, in the original problem, they give us this right here. So first thing I might do is separate, and that's what I wanted you to do here. Separate into two separate ones. Both have to be true, and so in B it says, write a sentence describing the possible values of x. You can see the answer is there. X can be any number between -5 and 4. And so in this particular problem, they're showing you 3 things that you should be able to do with these. Separate them, say in words, describe in words the possible values of x, and then C, you can see there's your graph that should look familiar to an and situation. And again, why are these points open? Because of these symbols here. So let's take a look here, and getting near the end, let's do this exercise here together. Rewrite the inequality as a compound statement of inequality. So we're going to look at this statement right here. And over here on the side, I'm going to go ahead and I'm going to rewrite this. I'm going to separate it. So there's one, and then I have this one. So I have actually two separate inequalities. And so I'm going to solve each one of them individually. And so as we write, we solve, and we're going to subtract 1. We're going to divide by 2. And on this side, we're going to get x is greater than -4. And then over here, with the other one, we're going to add or subtract 1. 4 minus 1 is 3. Divide by 2. X is less than 3/2, also known as 1 1/2. And so here are our two inequalities. We're going to write as a compound statement, which means x greater than -4 and less than 3/2. Here is my answer for A as a compound statement. Solve each inequality for x, then write the solution to the compound inequality. Well, we just did that actually. Okay, so initially the answer to A would have been the answer to A, in fact, writing this here would have been, here's the first part and here's the second part. And then in B, it says solve each, which I did here to get that and to get this. And so my actual answers aren't placed properly in this video and they're in the right spot, but you get the idea. C, write a sentence describing the possible values of X. Well, it's simple. X can be any number between -4 and 3/2. And then finally, the graph. The graph, if you're going to graph this, your answer would look like this. Open circle, and then somewhere 1/2, about right there, that's about where 3/2 is. 3/2 is somewhere in there. You're going to have an open circle here and shade in between because both have to be true. Both have to be true. Okay? So, in closing here, as we look to finish this out, I'm going to have you take a look at exercise 4, and I'm going to have you try exercise 5 on your own, and then we'll review that in class. So refer to exercise 4 when you're looking at exercise 5 to complete in your guided notes. All right, guys, talk to you soon.